This year, science didn't just push boundaries, it started resurrecting ghosts. Imagine a world where the dodo bird struts through island forests again, where the legendary dire wolf howls under the moon, and where extinct species are no longer stories from dusty bones, but living creatures walking the earth. In 2025, biologists made real steps toward bringing back lost animals, not as science fiction, but as working experiments with gene editing and cell engineering. And that was only one headline. From matter that breaks the laws of physics to alien-looking worlds giving off hints of life, to gene therapies that rewrite human fate, this year's discoveries didn't just expand science, they made it feel like the future had already arrived. Graphene, just one atom thick, was pushed to its mysterious Dirac point, and the electrons inside started flowing like a nearly frictionless liquid. Then came the shocker. Heat and electricity decoupled, smashing a textbook rule called the Wiedemann-Franz law. In plain English, graphene behaved like a tiny tabletop version of the early universe's quark-gluon plasma. That's not supposed to happen in an everyday material, and yet it did. Some measurements deviated by around 200 times from what the law predicts, and this isn't just trivia. It hints at new ways to move heat and charge in chips and quantum sensors. Now a chemistry curveball. Gold, the famously inert metal, formed a real compound with hydrogen under crushing pressures and heat, gold hydride. It appeared accidentally during a diamond-making experiment, then held steady long enough to study. If gold can react this way in extreme conditions, what else have we been missing about matter deep inside giant planets or fusion targets? New exotic compounds could unlock better models of planetary cores and maybe new energy materials. If you can change the rules of matter, you can change technology. And 2025 kept changing rules. Quantum information took a leap when researchers finally showed how to measure a W state, a notoriously tricky three-particle entanglement shared like a safety net between photons. Why care? Because robust, verifiable, multi-party entanglement is a cornerstone for next-gen quantum networks and reliable quantum teleportation protocols. This isn't sci-fi transporters, but it is how future quantum internet nodes will hand off information with near magical security. Let's swing to space and a biosignature headline that most people only saw once. Using the James Webb Space Telescope, teams reported the strongest hints yet of biology-related gases on a world 124 light-years away, K2-18b. The signals included compounds like dimethyl sulfide on Earth made by living things in the ocean. Caution is key. The community is still testing non-biological explanations. But if those molecules hold up, we're staring at chemistry consistent with life on a Hycean world, an ocean planet with a hydrogen-rich sky. That's a brand new neighborhood in the search for life. As several astronomers noted, evidence is exciting, not proof. So follow-up observations are underway. Reuters. Meanwhile, closer to home, Venus refused to be boring. New mission concepts aim straight at those mystery molecules in the clouds, like phosphine and even hints of ammonia that don't fit our known chemistry. A UK-backed probe concept is designed to fly through those clouds and test whether strange atmospheric chemistry or just maybe microbial life explains the signals. If there's even a tiny biosphere in that acid haze, it would rewrite what habitable means. Here's an engineering idea with wild implications. A proposed rectangular space telescope with a huge 20-meter mirror could find 24 or more potentially habitable exoplanets in just a few years, using technology we already understand. Think of it as switching from a fishing rod to a trawler, same ocean, way more catch. News.rpi.edu back on Earth, energy storage got a surprising reality check. Researchers demonstrated solid-state sodium batteries with energy density approaching today's lithium-ion cells, plus solid electrolytes for safety and cold weather performance. Translation: cheaper, abundant sodium may start competing not just for grid storage, but eventually for electric vehicles. This breakthrough enables solid-state sodium to compete with Li-ion for EVs, said researcher Eric Waxman. If sodium scales, it could ease supply crunches and lower costs across the clean energy economy. Biology turned heads too, starting with a gut microbe that acts like a quiet metabolic switch. An international team spotlighted a common gut bacterium that lowered body weight, reduced blood sugar, and increased bone density in preclinical work, with human trials already underway. One organism, multiple levers, cardiometabolic risk, and osteoporosis together. Microbiome therapeutics are maturing fast, and 2025 felt like the year they moved from interesting to imminent. Gene therapy delivered not just papers, approvals. In the US, regulators cleared the first cell-based gene therapy for a devastating genetic skin disease called RDEB. Doctors take a patient's own skin cells, insert a functional copy of the faulty gene, grow corrected sheets, and graft them back, or closing wounds that used to never heal. That's sci-fi medicine, now standard of care at select centers. Reuters. In England, the NHS approved a one-time gene edit that can functionally cure severe sickle cell disease for eligible patients. For families that have lived with pain crises, hospital stays, and limits on life, this is a generational pivot. The data persuaded the gatekeepers, and for people who qualify, the difference is night and day. The Guardian. Another preclinical spark. Prime editing rescued vision in a mouse model of inherited blindness, correcting the mutation with surgical precision, no double-strand DNA cuts. It's not in the clinic yet, but it's the kind of result that pushes a technology from promising to we need trials. Nature Chemistry closed the loop with a sustainability play. Greener ways to snap carbon-carbon bonds together, the step that builds medicines, agrochemicals, and advanced materials, were reported as safer and more scalable. If these roots take hold, manufacturing could shed toxic reagents and cut waste without sacrificing performance. That's invisible innovation, but it touches everything in your pharmacy and pantry. College of Natural Sciences. And one story that sounds like Jurassic Park, but is really conservation biology with CRISPR, scientists made a pivotal step toward de-extincting the dodo by growing the bird's reproductive precursor cells in a surrogate species. No, we're not releasing flocks tomorrow, and yes, ethicists are debating it hard. But the core tech, precision avian germ cell engineering, could also help save endangered birds by restoring genetic diversity. The Guardian Quick sprint through two under-the-radar breakthroughs worth bragging about. First, chirality-induced spin selectivity firmed up with new spintronic measurements. In some chiral molecules, electrons of one spin glide through while the opposite spin stalls at room temperature. That's like getting a built-in spin filter with no magnets. If harnessed, it could shrink spintronic devices and change how we do low-power logic. Phys.org. Second, citizen science flexed real muscle. Massive geotagged wildlife photos are now powering rediscoveries of lost species and tracking invasive threats in near real time, giving conservation an AI-boosted radar made by all of us with our phones. Quietly, that's how a lot of biodiversity wins will happen. Science Daily. Let's land this with a thought. the most thrilling part of 2025 isn't a single headline, it's the pattern. Materials behaving like early universe fluids, quantum states you can verify on a chip, planetary atmospheres, whispering chemistry we associate with life, microbes as medicine, gene edits as cures, cheaper, safer batteries, greener chemistry, conservation powered by code, and sometimes CRISPR. The future didn't arrive all at once. It arrived in pieces, and this year, a lot of those pieces clicked. So if someone tells you science is slowing down, tell them about the metal that isn't supposed to react but did, the planet that shouldn't smell like biology but might, the disease that haunted families for a century and met its match in a single edit. Because the story of 2025 is simple. The frontier is moving closer to home, and we're just getting started.